is independent of the path joining P1 and P2. Instead of this integration we will see integral P1 to P2. Integral P1 to P2 f of z dz is independent of the path joining P1 and P2. That is, here path C joining P1 and P2. Between 2 points there are so many paths, but this line integral is independent of the path joining the 2 points lower limit and upper limit P1 P2 whenever f of z is analytic. Whenever f of z is not analytic, then in some problems it is dependent on the path, in some other problems it is independent on the path. Example. Evaluate integral 0 to 1 plus I x square minus iy dz along first path y is equal to x square and second path y is equal to x. Here the 2 points P1 0 0 and 1 comma 1. This is your f of z. One is parabola, upward parabola path, and other is straight line. Both are starts from origin. Okay, because 0 0. Now I am going to do the first bit. Similarly, I am giving the answer for second bit. See the answer. Both are same or different. Independent of the path or dependent of the path in this problem. The diagram tells that one is this path, other is this path. This path is C1, this path is C2. Origin, x-axis, y-axis. C1 is nothing but y is equal to x square. C2 is nothing but, that is, y is equal to x. Okay. See, first bit. F of z is equal to how much? X square minus iy. First bit, C is y is equal to x square, that is C1. Okay, this C is nothing but here C1. From z is equal to 0, 0 stands for 0 comma 0, complex number 0, and z is equal to 1 plus I stands for 1 comma 1, not stands for, which is also written as, instead of n write TO2. So I told you yesterday, convert into one variable if possible. Line integral problem in vector calculus I have given. Same here also treatment. dy is equal to how much? 2x dx. Implies dy is equal to 2x dx. Just differentiate on both sides. So therefore, integral over 0 to 1 plus I x square minus iy dz is equal to, what is this dz? Dx plus I dy. First express in terms of x and y, and depending on the curve, if possible, express in terms of one variable. Yesterday I shown you problems. Okay, or you express this expression. What whatever you are going to integrate, that expression is equal to derivative of some expression. That will happen in f of z is analytic only. Yesterday that happened if f bar is irrotational, curl f bar is equal to 0 bar. So multiplication of these two gives first of all x square minus I into y is nothing but x square dx plus I into dy is nothing but 2x dx. Because of this converted into only one of the variable x, from these 2 points you write x limits, that is x is equal to 0 to 1. In these 2 points x lower limit 0, x upper limit is 1. And the simplification here 1 minus I, x square is getting common and then I kept 1 minus I outside, 0 to 1 into here this is dx common, 1 plus 2ix into dx. X square into 1 integration x cube by 3 plus 2I x cube x square into x cube integration x power 4 by 4, limits 0 to 1, and this is pre-multiplying by 1 minus I. So this is equal to 1 over 3 plus I by 4. Multiplication of two complex numbers which gives two real terms not containing I, two imaginary terms containing I, so, and then simplify. So 1 by 3, 1 into 1 by 3, and this is, this is 2 over 4 means I over 2, this term, and minus plus 1 over 2 plus I times minus 1 over 3 plus 1 over 2 after taking I common. So this is simplifies to 5 plus I by 6, final answer. I am giving the answer for second bit, later you check whether the path is independent or dependent. Okay. Second bit, answer 5 minus I by 6, later you check. In the same way, if it is not possible to express in one of the variables, then you express entire the term integrating, the term going to integrate is equal to derivative of some expression. Whenever it is not in terms of one variable, then you express, then you write this term going to integrate is equal to derivative of some value, derivative of some expression which I shown you in the previous class, that is yesterday's class. But there happened curl f bar is equal to 0, f bar is irrotational. The same thing here happened if f complex function is analytic, f of z is analytic. Cauchy's integral theorem, very important. These two theorems helps to find without converting, writing all these steps and finding limits, okay, without integrating, without limits, without one variable verification, converting into, without graphs, we can get the results, provided the curve should be a closed curve. Here it is open curve. Open curve means endpoints are not equal. Closed curve means endpoints are equal. If f of z is a f of z is analytic in a simple connected region are bounded by a closed curve C then integral over C, this is called contour integral, integration over a closed curve, f of z dz is equal to 0. So this is a closed curve, this is a region R. This is called simply connected. Whenever there are no gaps in the region, that each gap the function is called not defined, okay, not analytic. Whenever there are no gaps, that is at every point inside the region it is analytic, that is called simply connected region. For example, say this is a curve and there is a inside which I have not shaded, that part is called gap. Such gap is there, that part is called, this region is called doubly connected. Similarly to two gaps, triply connected, that is called multiple connected region, okay. Cauchy's integral formula very, very important. These two terms helps a lot. First of all, C is a closed curve. It helps a lot to avoid, that means without integrations and without simplifying, that not without simplifying, without integrations and curves and drawing the curves and converting into one of the variables, what we have done in previous problems. Okay, first of all, C is a closed curve. Without integrating, we will get the answer, even though it is integration problem. If f of z is analytic in and on a simple closed curve C, in and on a simple closed curve C, and A is a point inside C, then f of A is equal to 1 over 2 pi I integral over C f of z divided by z minus a dz. See, f of z is analytic in and on a simple closed curve C, a curve C, a point inside denoted by A, okay. So this is the region R, shaded part. Inside the region I have taken a point A. At this point, how to find function value? This is 1 over 2 pi I by integral over C f of z by z minus a dz. But based on this result, the question not asked like this, find the value of f of A. The question asks, find this integration value. That means bring this 2 pi into that side. So this can be written as integral over C f of z by z minus a dz is equal to 2 pi I into f of A. Just keep this result in a box. That is very important. That means this function is defined at z is equal to A, but f of z over z minus a is not defined at z is equal to A. Still that integration value is given by 2 pi I into f of A. Similarly, just this is also keep it in bracket. Similarly, integral over C f of z by z minus a whole square dz is equal to 2 pi I by 1 factorial f dash a. So when it is whole square, this is the answer. When it is whole power 1, that is the answer. All these are came by Cauchy's integral formula, derivative of analytic functions. integral over C f of z by z minus a whole cube dz is equal to 2 pi I by 2 factorial f double dash a. That is the answer. So on integral over C f of z by z minus a whole power n plus 1 dz is equal to 2 pi I by n factorial f nth derivative f of z n derivative set z is equal to a. N factorial 2 pi a by n factorial f nth derivative a z minus a raised to n plus 1. Just the difference between the derivative and here the power in the denominator exponent is 1 only. Factorials everything. Okay. Now I will give you where you apply this Cauchy integral formula, where you apply Cauchy integral theorem. First of all, C is a closed curve. Okay. Next, the procedure I am telling where you apply in this. First of all, the term going to integrate, whatever it may be, go to your denominator of the given integration term. Equate to 0, find the values of z. That means our intention is the term going to integrable, which is not defined at some points of z, that we have to find first. That is obtained by equating denominator of the given integrand, given integration z function. Denominator equate to 0, you will be getting z values. At that points, the function is not analytic. And check these points lies inside the curve or outside the curve. If all the points outside the curve, then apply Cauchy integral theorem. Answer of that integration is 0. If any point or 2 points inside the curve, I have given already a single point A is inside the curve, then apply Cauchy integral formula, and depending on that, say A is inside, the corresponding factor is z minus a whole power 1, whole square, whole cube, according to this answer. So, in Cauchy integral formula, every z term is denoted by f of z. All the terms denoted by f of z. In this, separate z minus a, where the point A inside the curve, separate the factor z minus a, and the remaining terms send into numerator. That is denoted by f of z. Okay? So, here, integral, this is C, closed curve. Integration over C. Okay. Now in this, 2 pi I into f of a. Integral C f of z by this. This statement is nothing but integral over closed curve C. So in both results, in the given integration term, whatever the z term, first equate denominator to 0, find the corresponding z values, and check that point inside the curve or outside the curve. If the points outside the curve, then apply Cauchy integral theorem, answer is 0. If any point inside the curve, then apply Cauchy integral formula.